So far, the trig functions that you know how to graph are sine and cosine, and all we've been doing in class is graphing one cycle of sine and cosine. So I usually just gave you the right-hand side of a coordinate plane for you to graph on. Now what we're going to do is we're going to graph two cycles. Remember, one cycle is one of the patterns. If you're going to graph two cycles, that's two of the patterns. Now, if I'm going to be graphing sine, which is what we want to do first, I want to remind you of a couple of things. First is the general equation for sine looks something like this. So I'm going to just graph the parent function, y equals sine of x, and talk about the general observations that you should have made. In y equals sine of x, the parent function, a is 1 because a is a number out front, and b is also 1 because the number in front of the x is 1. Now, the a is the amplitude, which basically gives us our max and our min before transformations. The b impacts the period. So the period of a graph is always 2 pi over the absolute value of b. So that would be 2 pi over the absolute value of 1, which is 1, or 2 pi. Now, when you are graphing sine, I'm going to do it the way we did in class. I have 4 tally marks. The first tally mark is 1/4 of the period length. The second tally mark is 1/2 of the period length. The third tally mark is 3/4 of the period length. And then the fourth tally mark is the full period length. So 1/4 of 2 pi is pi over 2. 1/2 of 2 pi is pi. 3/4 of 2 pi would end up being 3 pi over 2. And then the full period is 2 pi. The amplitude is 1, so that's going to impact our y-axis. You could use a scale of 1, so it'll go right here, but then it's going to kind of look smushed. So I usually use a scale of 1/2 and make this 1 and that -1. Because it's sine, the pattern would be the origin, max, intercept, min, intercept. This is one cycle. If I wanted to do another cycle, I could either move it to the right or to the left. Now, we should have a nice curve. Okay, it's going to go max, min, max, min, max, min. It's going to oscillate like that forever. Or if I'm going to the left, it was just a max, so it's going to go down to a min. Max, min, and continue oscillating forever. So I'm going to try going to the left. The left is just the negative of these values that we see here. So this is negative pi over 2, negative pi, negative 3 pi over 2, and 2 pi. So it was at an intercept, and I already had a max, so now it's a min, x-intercept, max, x-intercept. If I wanted to keep going, min, x-intercept, max, but it only said 2 cycles. Let's do cosine. So I'm going to do the parent function of cosine as well. It's the same thing where A gives you the amplitude and B impacts the period. So the period here is 2 pi over 1, which is 2 pi. Same thing as well with the scale. 1/4, 1/2, 3/4, and the full period length. Amplitude is the max and the min. I'm doing a scale of 1/2. to get 1 and -1. Now cosine has the pattern max, x-intercept, min, x-intercept, max. So this is what the curve looks like. I could continue to the left, so it's at a max, goes x-intercept, min, max, x-intercept, max, and keep going. Or I can move it to the right. So since I moved it to the left last time, I'm going to continue it to the right this time. So I need to do 1, 2, 3, 4 more tally marks. And I just repeat the pattern using the same amplitude as well. So it's max, x-intercept, min, x-intercept, max. See how this is yet another cycle. We're just putting the two together. Tangent graphs have different characteristics. So we're going to graph y equals tangent x. This is going to be the parent function. Now, if we think about tangent, I want you to remember that tangent in the unit circle we found by doing y over x values. So if we think back to our unit circle, we'll be able to get the shape just like what we did in the introduction to sine and cosine. If this is my unit circle, for sine it was really simple because we just wrote down all the y values. For cosine we just wrote down all of the x values. For tangent it's going to be y, let me pick one, y over x. So this divided by this divided by this, and we're going to go all the way around. Now, whenever we have pi over 6 and pi over 3, tangent's either going to be root 3 over 3 or root 3. And that's not a point that's so easy to plot on a coordinate plane. So instead, we're just going to use the quadrantal angles and the pi over 4s to get our coordinates for looking at the pattern of a graph. So if I start here at 0 degrees, or actually we're going to use 0 radians because the x-axis is normally in radians. 0 radians will have tangent of y over x. So 0 divided by 1, which is 0. So I'm going to write that down. Theta, tangent theta. At 0 radians, we had 0 over 1, which was 0. Next is going to be pi over 4. So for pi over 4, we have root 2 over 2, root 2 over 2. So this divided by this would give me a positive 1. The next quadrantal angle is pi over 2. So it's y over x, or 1 over 0. Now we cannot divide a number by 0, so this is actually going to be undefined. And I'll show you what that looks like on the graph here soon. 3 pi over 4 is the next one that I'm interested in. Y over x gives me a negative 1. And I'm just going to keep going until I get to 2 pi. At pi, it's y over x, so 0 over negative 1, which is 0. Next would be 5 pi over 4. We have y over x, so that would give me a positive 1. Then 3 pi over 2 is the next quadrantal angle. Y over x, negative 1 over 0, which is undefined. Then we have 7 pi over 4. Right here. So y over x gives me a negative 1. And last is 2 pi, which is 0 over 1, same as 0 up here. So now we have created a table of the values for tangent using the unit circle. If I wanted to take these points and put them onto the graph, this is what it's going to look like. So at 0, it'll have a y value of 0. So here's 0, 0. I'm going to go by a scale of pi over 4 because that's my next one. So pi over 4 would have a y value of 1. Pi over 2 is undefined. So that means the tangent will never ever have a value of y at pi over 2. So we would put an asymptote there. At 3 pi over 4, it was -1. At pi, it was 0. At 5 pi over 4, it was 1. At 3 pi over 2, it was undefined, so an asymptote. Now I'm going to stop there just because I ran out of space. This is enough to show you what the curves of tangent will look like. So one cycle of tangent will be an asymptote to an asymptote. And the function of tangent will get closer and closer and closer to, but never quite touch, these asymptotes. The cycle would be a point below the x-axis, and we would go down whatever the a value is. So the a was 1 in the parent function. Then we would have an x-intercept. And then we would also have, on the next tally mark, a coordinate that moves up whatever the value of a is. The length is called the period. This is one cycle. And the period from pi to 3 pi over 2, that's a difference of pi. So it turns out, for sine and cosine, the period is always 2 pi over the absolute value of b. Tangent is 1 pi over, tangent has a period, I should say, of 1 pi over the absolute value of b. A is not a max or a min. It just corresponds to a coordinate. You can graph any cycle. I'm going to graph 2 cycles. So we already have 1 cycle here, and we have half of 1 cycle here. So I'm just going to finish the cycle. I already have the point to the right of my x-intercept, which moved up. So the point to my left of the x-intercept is going to go down whatever the amplitude was, which was 1. And the next tally mark will be the asymptote. So I'm just repeating the pattern.